Hello everyone, we are from Team Fantastic 4. I'm the team leader Pashrosha, and here is all about our project. On the 10th of May 2024, the largest geomagnetic storm in 20 years hit the earth. Across 12 American states, GPS guided trackers stopped midfield in the middle of the planting window. One storm, one crop, and like $500 million are on the deck. No satellites failed, no grids went down. The system all worked, but the decisions didn't. 30 seconds vocabulary, nothing after this, and the black box. Okay, let's go. CME is a billion tons of plasma leaving the sun. G, S, and R are one of the five severity scales. BZ is the direction of the arriving magnetic field. Southern drive storms, northern doesn't. Like Donkey, Goes, and DS-Cover are the public data feeds, like the states we got. Space weather is one of the few hazards where the warning is free and the response is not. Aviation loses high frequency radio over the poles, and single unplanned reroute runs into six figures. Grid operators get induced current hitting transformers. During the May storm, roughly half of the everything is low Earth orbit manured at once, and the collision screening was effectively impossible for the days. The tail is not small either. Lois models an extreme space weather scenario at $2.4 trillion globally. Cambridge researchers put a severe US blackout at $41.5 billion at a day. Now, here's the gap. Almost all the investments in the field goes upstream. Better physics, better models, better forecasts. Almost none goes to the last 30 seconds, where the human being has to commit to a particular action using four data sources that quickly disagrees with each other. So this is the space where we work.
So hi guys, my name is Neil Daftari. I'm one of the team member of Fantastic Four, and let me take you over to the product that we have built. So this is the homepage that where we present the aviation, power grid, maritime, and telecom. These are the four industries that are getting targeted through our product. Now let me take you to the product that we have built. We have built an AI native space weather platform that hands operators verified orders, not alerts. So for solving this problem, we have built a 5-stage pipeline that includes CV detection, ML impact, agentic advisory, deterministic verifier, and the delivery, the product that the final output that we give to you. So in Solar input, there are 4 different data from where we get the data as prescribed before. Now the CV detection layer converts them into a storm event IDs, which then is taken as an input, and the other data that are taken as an input through the ML impact layer, and then this ML impact layer gives us GPS error, HF blackout, etc. So now this data and the conclusion from it is derived from the traditional computer vision and machine learning layers. We pass it on to the modern age agentic advisory layer, in which 4 advisory agents run parallelly. These 4 advisory agents are for aviation, maritime, power grid, and telecom. Now this agentic advisory layer runs such a way that it is a deterministic G-scale routing fans out to 4 industry agents in parallel, each grounded by RAG on the real rule books behind 10 layers of anti-hallucination control. As we know that LLMs often hallucinate, so to solve that problem we have a 10-layer hallucination control and an 11-layer guardrail to solve this problem. So agentic advisory takes on the data that is given as an output from the CV and the ML layer, and converts and fact checks it entirely through and through from the 4 cited PDFs that we take as a consideration. These 4 cited PDFs are the PDFs that are retrieved from the regulatory official database. Now moving forward to how the deterministic verifier works. So we have an 8 block deterministic verifier, in which 5 are the major red blocks, which directly blocks if not satisfied, and the other 3 are the flagging blocks, which flags and gives the output. Now we have an LLM loop running over this deterministic layer, deterministic verifiers, in such a way that if a particular thing is blocked, it runs the LLM loop again and gets the corrected answer. So we deliver this product to you in live stream, and we shared this to traces. 4 decision that defines it. Deterministic where safety demands it. The G-scale to industry severity matrix is a hardcode lookup table, not a model output. G4 storm always produces critical aviation status, never high, because sampler rolled differently. The LLM only does the part LLMs are good at, which is turning a severity tier plus the retrieved regulatory text into a readable numbered step. As I prescribed before, LLM is used as an bridge between operator and the data that we get. So let's say we get some data from the reg database and we get some data from the ML and CV layer. Now we check it across through a hard-coded matrix, and then we come up with a conclusion. Now this conclusion is converted into a natural language through LLM so that an operator can understand it. The LLM is never the last word. Physics from the authoritative source as prescribed before, and failure is designed in, not discovered. This is our team: Neil, Pashwa, Priyanshu, and Tirth. Let me take you over to the problem. So the problem is that in this current industry, signals are free. Signals are publicly available through NASA official APIs and other data sets. But the last mile does not exist. When the sun throws a coronal mass ejection at Earth, 4 industries lose capability within hours. NOAA alerts, Donkai kinematics, GOES flare data, and Discover solar winds are all public and all free. What nobody ships is the step between a measurement and an order an operator can act on at 3 a.m. So these are the basically 4 gaps between data and decision. Raw alerts are not decisions. The rule books are the PDFs. Generic LLMs are unsafe here. As prescribed before, when LLMs are not backed with proper physics and the proper data set and the proper procedural live regulatory forms, it generally responds with a generic response which is not useful at all in the particular situation. And also nothing is auditable. Regulated operators cannot act on an output they cannot trace back to the cited procedures and a measured input. Without provenance, a correct answer is still unusable. So this is what breaks in the industry and what it costs. In aviation, in power grid, in maritime, and in telecom. The raw signal that already exists are the NOAA data storm alerts and watches, the NASA Donkai API, CME kinematics, the GOES XRS from where we get the flare classes, and the Discover at L1 from where we get the solar wind, BZ, and speed. Let me take you over to our dashboard. So the dashboard is the main thing as of now. So this is the place, this is the portal where an operator can see each and everything that has been happening. So for demo, let me take you over to one event data in October that happened in October 2024. So when I click on the event and I click on the button run live, so this is the event. It gives a confirmation to start a run. As you can see it over here. Let me start the run. Now the pipeline stream will open where you can see the entire logs of each of the 4 industries that we are targeting: aviation, grid, telecom, and maritime. As you can see it over here. Now let me take you over to the main portal, the main tab, which is the advisory panel. The advisory panel gives you what the ML and CV layer inputs and the decisions that can be derived from it. As you can see it over by the verification layer, by the deterministic verifier layers and the other layers, we can say that it is passed with corrections. It requires a human review and there are no guardrail flags that are reported over here. So these are the 5 steps that an operator should take based on the kind of storm event that has been occurring. So these are the cited resources from where the data is being seed. The same is for grid, maritime. As you can see in maritime, there has been something that is flagged, which is citation gap. So the advices that may have been given to you might have some citation issues. Now, before the entire layer used to take 65 to 80 seconds, but after the task that was assigned to us to extend our MVP into such a way that it gradually checks the system, it reduced to 0.31 seconds. Isn't that fantastic? So the next is the verifier layer. So the verifier layer verifies all of the 4 industries and the input that has been given into those industries. So in aviation, as seen in the advisory layer, you can see the same tags are mentioned over here. So the next is provenance trace. So as prescribed before, we do not give anything which does not have a provenance trace to it. So we store all the traces and present it to you so that a developer who, when debugging it, can check it and verify it. So as you can see in aviation, everything from raw data to detection to impact to retrieval to verify and the output. Same for the other 3 industries. Now let me take you over to the LLM. Let's say I have a question. Why we are using 5 megahertz as mentioned in the aviation advisory and why not 8 megahertz? So let me ask it to him. 5 megahertz and not 8 megahertz. So as you can see, the agent answers. The advisory uses 5 megahertz because for the net frequency allocation, frequencies below 6 megahertz preferred at night and those above 5 megahertz during the day. 5 megahertz is the boundary where the ionospheric conditions shift from nighttime to daytime optimal band, so it is chosen to match the expected ionospheric state for the route. Isn't it fantastic that you can ask an agent if you have some queries in the advisories, you can verify it, you can the entire system is not blindly dependent on anything. It is entirely physics guided and verification from a matrix that has been a rule engine, that acts as a rule engine. Now moving forward to the system health, as you can see in the system health, it is pulled every 15 seconds and you can see each and everything if it is functioning well or not. As you can see, for the APIs, for the detection, for the ML models, for the Gen AI module, and for the knowledge base. So thank you.